In this video lecture, we discuss carbon-14 dating. 18% of human mass is carbon. That means 1 gram of living tissue or dead tissue or bone contains 0.18 grams of carbon. But of that carbon, 1/trillionth of it is the isotope of carbon called carbon-14, C14. And so in a gram of living tissue, this many femtograms of carbon-14 will be found. We've used 10 to the negative 12 as 1/trillionth and converted it into 10 to the negative 15 grams. 10 to the negative 15 prefix as a power of 10 is the word femto. You've probably never seen that before. F-E-M-T-O. And so in 1 gram of living organisms, there would be found 180 femtograms. But the thing is, when this animal or living thing stops breathing and eating, it stops recycling or refreshing its carbon. The carbon-12 in the human remains there forever. It doesn't decay, it's stable, but the carbon-14 is constantly decaying by beta particle emission. It's disappearing. And so as time goes by, there will be progressively less and less and less carbon-14 in that 1 gram of, perhaps it's a bone of a fossil. That bone, once part of a living animal, contained 180 femtograms of carbon-14. But as years go by, there's fewer and fewer carbon-14 atoms in that 1 gram sample of bone that you extracted from the fossil. Let's work a problem involving the dating of a bone taken from a human fossil remains. Suppose it happens that 1 gram of human fossil bone is measured to contain 135 femtograms of carbon-14. How long ago did that organism, that human, stop eating, stop breathing, stop having its carbon-14 refreshed? In other words, how old is that bone? Well, the solution appears here. The half-life of carbon-14 is 5,730 years. In the previous video lecture, I described how to calculate the so-called decay constant. It's part of the exponential decay equation. We calculate lambda by dividing 0.693 by the half-life, and this is what you get in inverse year units for the decay constant for carbon-14. Substituting the number of femtograms now, the mass of the carbon-14 that's found in the 1 gram sample of the bone that was extracted. Originally there were 180 femtograms before that organism died. We complete the exponential decay equation. If you use your equation solver to solve this, make sure that you include the quantity t inside the parentheses here. If you put it outside the parentheses, the calculator will think you are multiplying all of this by t. So t goes inside the parentheses. Solving this equation using my solver, I obtained 2,378 years. That's how old those fossil remains are. I mentioned in the previous lecture how we, years and years and years ago, were able to date, attach a time working backwards. A number of years ago, that the flax plants that were used in Italy to weave the cloth that was later purported to be the burial cloth of a famous religious figure, we determined those flax plants were pulled out of the ground. They died about 600 years ago, not 2,000 years ago. That concludes this lecture. I hope you learned something.